Hey everyone, and welcome to a new 4D systems video. In this quick guide, we're going to go over something that is really important when working with 4D displays, and that is understanding screen coordinates. For this example, I'm using the Gen 4 ULCD 28DCT, and I'm working in the designer environment. So this is all code only. No widgets, images, or visual layout tools like the Visi or VisiGenie environments. We're just drawing directly to the screen using 4DGL. When you're in Designer, every piece of text, every line, rectangle, and shape has to be placed using an X and Y position. Once you understand how that works, placing things on the display starts to make a lot of sense. The main thing to understand is that the screen is basically a grid. Every position on the screen has an X value and a Y value. X controls the horizontal position and Y controls the vertical position. On the display, the top left corner is the starting point. That position is X0, Y0. From there, as X gets bigger, you move further to the right, and as Y gets bigger, you move further down the display. So you can kind of think of it like an inverted grid. Instead of moving upwards on the y-axis, you move downwards. Because I'm using the Gen 4 ULCD 2.8-inch display in portrait orientation, the display is 240 by 320 pixels. So the X value goes from 0 to 239 and the Y value goes from 0 to 319. If you were using a different display or if you rotated the orientation, those numbers would change. So always keep your display size and orientation in mind. When you load into a designer project, it will come with print hello world already in the code. Since there are no coordinates specified, it will simply be drawn at the origin, which is the top left corner. If I move it to position x20, y20, and then print the same text, the hello world print will now appear in the upper left quadrant of the screen, but not in the corner. If I keep the Y value the same, but increase the X value, the text moves to the right. And if I keep the X value low, but increase the Y value, the text moves down the screen. So the basic rule is X moves across and Y moves down. That same logic applies to shapes as well. For example, if we draw a line, we give it a start coordinate and an end coordinate. Here in GFX line, the line starts at X20, Y40 and ends at X200, Y40. Because the Y value stays the same, the line stays level, and because the X value changes, it stretches across the screen. So that gives us a horizontal line. The same rule applies for a vertical line. We simply do the opposite and keep the X value the same. So now the line stays at the same X position but moves down the screen. Rectangles work in a similar way, but I like to think of them more as two corners. The first X and Y position is one corner, usually the top left, and the second is the opposite corner, usually the bottom right. So if we use GFX rectangle 40, 40, 200, 120, this rectangle starts at X40, Y40 and ends at X200, Y120. Once you understand this, drawing any type of shape becomes extremely easy. You're placing things based on where they actually sit on the display. Now to bring everything that we just learned all together, let's revisit the demo that I showed at the start of the video. It's a kind of coordinate guide. This is the best way to help visualize and understand everything that we just displayed on the screen. Let's take a look at the code to understand how this works. The first thing we do is draw a border around the whole screen. Because this display is 240 by 320 pixels in portrait mode, the last visible X coordinate is 239, and the last visible Y coordinate is 319. So drawing from 00 to 239, 319 gives us a border around the usable area, similar to how we drew a rectangle earlier. Then we draw the center guidelines. The vertical line is at X120, which is roughly halfway across the 240 pixel width. Same rule applies for the Y line. So now we can actually see the center of the screen instead of just guessing where it is. Then we label all the corners with our coordinates. This just makes the coordinate system more visual because now the screen is showing us how the coordinate space works. After that, I've added a few examples. There's a horizontal line showing that x increases and a vertical line showing that y increases as we move down. Then there are a couple of rectangles placed at specific coordinates so you can see how those numbers turn into actual positions on the screen. And then at the bottom of the demo, I've added a moving dot. This is just a simple way to make the coordinate system feel a bit more alive. The dot moves from left to right while printing the current x value. The important thing here is that the y position of the dot stays the same, so it stays on the same horizontal path. One more useful tip for this demo is that I'm not clearing the entire screen every time the dot moves. It only clears the small area where the animation is happening. That means the rest of the coordinate guide stays on screen and only the moving part gets updated. This is a good habit to get into because if you clear the whole screen every time something changes, the display can become flickery or messy. But if only one section is changing, you can usually just clear that section and redraw it. This same coordinate logic applies to touch as well. When you read touch input from the display, you're also working with x and y values. So coordinates are not just for drawing. They are also how we connect the visual interface to interaction. Whether you're placing text, drawing a rectangle, creating your own button, or checking for touch input, it all comes back to the X and Y grid. And once you understand that, building interfaces becomes a lot less intimidating. That is everything for this tutorial. If you would like to download Workshop 4 or are interested in any of our products, please visit the 4D Systems website. If you need any help with the 4D display, visit our resource center and forums. And of course, follow and subscribe for more videos. Thank you for watching.